Hello class, I'm delighted to meet all of you in this meeting today. Is everyone doing well? I hope everyone is doing well, and please take good care of your health. So today we will be learning about arithmetic and geometric series. But before we begin, please allow me to introduce myself. As you can see on the screen, my name is Josua Manihuruk with my ID number 2013 011056. I come from class 6B in majoring in mathematics education. Alright, I believe it's enough for the introducing and greetings. Let's dive straight into the content. As I mentioned earlier, we will be learning about arithmetic and geometric series. But before that, I want to ask you one question. The question number one is, how many types of series? How many types of series? There are two types of series. Number one is arithmetic series, and number two is geometric series. So first, we will discuss about arithmetic series. What is mean by an arithmetic series? As you can see on the screen, the definition of an arithmetic series is the sum of the terms of an arithmetic sequence. And the order of terms in an arithmetic series is where the next terms in the series is the previous term plus the difference from the previous terms, and the difference must be equal. That's the key. So the key word is difference must be equal. For the example, 1, 4, 7, 10, 13, 16, 19, 22, and soon is an arithmetic series. Why? As you can see on the screen, the next terms in this series is the previous term plus the difference. And in this example, the difference is plus 3. As you can see, 1 plus 3 is 4. So, the next series of this arithmetic series is 7. 7 plus 3 is 10. So, the difference of this arithmetic series is plus 3. Okay, next. As you can see on the screen, we have a formula to find the sum of the terms from the first term to the end terms, which is as follows. Sn equal n per 2 is multiplied by 2a plus n minus 1 and so forth, and multiplied by b. Sn is sum of the first n terms of an arithmetic sequence. N is the number of terms, A is the first terms, and B is the common difference. And I have a question for you. From the sequence 7, 9, 11, 13, 15, 17, 19, 21, 22, 25, and 27. From the sequence, calculate the arithmetic series for the first 25 numbers. From the question, we get A equals 7, the difference or B is equal 2, and N is equal 25. Now substitute into the formula of the arithmetic series so you can find the first 25 number. Okay, if you substitute this question into the formula correctly, you will find the answer will be 775. Otherwise, you will match it incorrectly. Okay, let's continue. Lesson number 2 is geometric series. What is mean about geometric series? As you can see on the screen, in mathematics, it's a geometric series is the sum of an infinite number of terms that have a constant ratio between successive terms. For the example, the series 2 plus 4 plus 8 plus 16 plus soon. 2 plus 4 plus 8 plus 16 plus soon. And we have a formula for geometric series is A multiply R plus A multiply R rank 2 plus A multiply R rank 3 plus A multiply R rank 4 plus soon, where A is the coefficient of each term and R is the common ratio between adjacent terms. As you can see on the screen, the example is the geometric series. Why? As you can see on the screen, the definition of geometric series is the sum of an infinite number that have a constant ratio. So, the ratio for this geometric series is 2. Why? We can see on the screen 4 per 2 is 2, 8 per 4 is 2, and 16 per 8 is 2. So this example is geometric series. And let's see the formula for a geometric series. The formula number 1 is UN equal A multiply R rank n minus 1, which R equal UN per UN minus 1. Number 2, Sn equal A multiply A R rank n minus 1 per R minus 1 for R more than 1, and Sn equal A 1 minus R rank n so forth per 1 minus R for R less than 1, where A equal first terms of geometric sequence, R is a ratio between terms, and is the order of the last terms added up, and UN is n the term. So, for geometric series, I have tasks for you to find the first number of geometric series. The sum of the first 6 terms of geometric series 2 plus 6 plus 18 plus soon is, okay, as you can see on the screen, we have the solution where A equal 2 and R is equal 3. We have R equal 3 by, we got 3 is by obtaining by dividing the next terms by the previous term, as we can see on the screen. The next is 6, the previous is 2. We obtaining 6 per 2 is equal 3, so we have ratio is 3. Okay, now we substitute for the formula. The formula is Sn equal A multiply R rank n minus 1 and so forth per R minus 1. So S6 equal 2 multiplied by 3 rank 6 minus 1 and so forth per T3 minus 1 equal 2 multiply 729 minus 1 per 3 minus 1. So we have the answer as 6 is 728. If you substitute correctly, you will get the number. Otherwise, you will match it incorrectly. Any question? If you have question, you can ask me. But before that, I have homework for you about this meeting, and you can submit it through the link I have provided. Alright class, that concludes the explanation of the material for today's meeting. I hope you have understood it, and please take care of your health. Lastly, I would like to express my gratitude and see you in the next meeting. Thank you and goodbye.